All right. So essentially, anything beyond 2 steps, we are calling multi-step equations. And there's three main steps to this. It doesn't mean that there are only 3 steps in solving the equation. I want to be clear about that. Sometimes there's definitely more than 3 steps, but the process, each one of these things could be more than 1 step. But if you go through the process, you'll end up working through the entire thing. So the first thing that you should be looking for, first thing to look for is to distribute. If there is a place to distribute, that is where we're going to start. Now, if you look at example 1, is there anywhere to distribute on example 1 down here? I see some people shaking their heads no. Why not? When do we distribute? What's the thing that we see that tells us, oh, we need to distribute here? Parentheses, yeah. And there aren't any parentheses here. So if there are no parentheses, then we cannot distribute. So distribute if possible. The reason why we want to do that is because you can't solve an equation that has a set of parentheses in it. You have to be able to get rid of that parentheses to work with what's inside of the group. Kind of like when we were going back with our 2-step equations from last week. These last few problems that we saw at the bottom, we had to get rid of the denominators first because this group on the top was sort of locked away, and we had to basically like unlock it by getting rid of the denominator. You can imagine these on the numerator here in parentheses, and then getting rid of the denominator gets rid of those parentheses. So it's similar to distributing in that we want to be able to basically unlock everything that's in a group or in parentheses or on a numerator by itself. So we want to be able to get rid of that. So if you see a place to distribute, that should be the first thing that happens. After that, step 2 is to combine like terms. Step 2 is to combine like terms. So we'll go ahead and we'll combine our like terms. Once we've distributed, if we can, like on number 1, there's no distributive property that can be used there at all. So we're going to end up starting by combining like terms. And then once you get to step 3, this step is a little bit open-ended, is a good way to say it. And then we're just going to say solve. And most of the time, once you get to this part here, solve is usually about 2 steps. So essentially, once we get to step 3, you should be looking at a 2-step equation, kind of like what we did here. So once you've distributed, once you've combined like terms, then your problems will look similar to these ones here where we started with last week. So we're basically adding on 2 additional things to our 2-step equations. So let's just jump into our examples here. So I want to, this will be a really good review today because we're going to be reviewing combining like terms. We're going to be reviewing the distributive property. We'll be reviewing 2-step equations. So there's a lot of things that we'll be able to review today. So I'm going to get your tests back to you today so you can look at them to see how you did. I will need to collect those back. But if you were struggling a little bit with the combining like terms, distributive property, or equation solving on the test, hopefully today will clear up some things here and there for you. So our first example here, number 1, it says 9x plus 1 minus 7x minus 5 equals 20. So first thing we're always going to do, make sure that we've got our line right down through the equal sign, because we want to make sure that this equal sign stays in the same place vertically as we move down this process. From there, we're going to see if there's any distributing that can be done. The answer to that is no, we're not going to be able to distribute at all in this one. So the distributive property is out, which means we're going to be looking for like terms that we can combine. And I just want to remind everybody about combining like terms. Like terms are things that have, yeah, if you want to, yeah, if anybody wants to grab some, like, or just the right way. Yeah, if you want to grab some colored pencils or whatever, if you want to do that for the distributive property, not a lot of them are very sharp. And unfortunately, there's a lot of just white colored pencils in here, which outside of art, I don't really see being very useful. And since this is not an art class, I don't think those are going to be all that useful. So we're going to start here, basically putting, you know, shapes or whatever around the like terms. Everything with an X is a like term. So the 9X. And is this, am I going to put a set, am I going to put it around the 7 or the negative 7X? Is it going to go around just the 7X or the negative 7X? Yeah. Or the minus 7X. So remember that when you were combining like terms, you were looking to the left of the term to see if it's a positive or a negative. Now the other ones are going to be our regular numbers. So that'll be a 1 and a minus 5. So I'm going to put the 1 and the minus 5. Now I want to make this very clear. I am only combining like terms on the left. I'm not doing anything with this negative 20 over here. This negative 20 is a single value. You cannot combine like terms between both sides of the equal sign. You can only combine like terms on one side at a time. If there was more stuff over here that we could put together with the negative 20, then we would do that. But we're only combining like terms where there's multiple things on the side of the equation. So we're starting by putting together 9x and a negative 7x, or 9x minus 7x. What is 9x minus 7x? 2x, yeah, because we're just, all we do, remember, is we're subtracting the numbers. We keep the variable, we're subtracting the numbers. 9 minus 7 is 2. Oops. 9 minus 7 is 2. And we have our variable x. Now the other one is a 1 minus 5. Now, once again, if you are not confident about your integer operations, adding, subtracting, multiplying, and dividing with positive and negatives, grab a calculator, use a calculator. 1 minus 5, that's negative 4. So we're going to write 2x minus 4 equals negative 20. So we put together the 9 minus 7x, the 9x minus 7x, we put together the 1 and the negative 5, we got 2x minus 4 equals negative 20. So we didn't worry about step 1 because there was no distributing to do. Step 2, combine like terms, we've done that. Step 3 says to solve, usually it's about 2 steps. So if we look here, this is a 2-step equation, just like what we saw last week. So what's our next step? What do we do now to solve for x? Because the whole idea of equation solving is to get x by itself. So if I back up a step real quick, we can't solve for x here if it's in multiple places. We can only solve for x once it's combined with other things with x or y or whatever the variable is, and we have to end up getting it by itself. So we can't get it by itself if it shows up in 2 places, right? So that's why we're putting it together. So what do we do next to solve for x here? What's our next step? You saw quite a few problems like this on your test and on the review. What is it? Add 4 to both sides. Good. So now we have to undo the subtraction. And on the left side, negative 4 and positive 4 cancel out. We bring down the 2x because there's still 2x left. Negative 20 plus 4. Again, if you're having a hard time with integers, negative 20 plus 4, it's negative 16. Looks like I need to write smaller because I'm about to run out of room. What's my last step? What are we doing here to finish this off? Got to get rid of the 2 times next to this x. How do you undo a multiplication? Divide by 2. Good. So the 2's cancel on the left. Negative 16 divided by 2 is negative 8. So x equals negative 8. So that is the answer to that first problem. All right, moving on. And if you have questions about the combining like terms or the steps that we're doing after it, stop me, raise your hand, ask questions, because equation solving is only going to get bigger from here. It's only going to expand. So if you're struggling with what we're doing here, you got to let me know so I can help you out. All right. Problem number 2. We have our regular number 91 is equal to -7 times in parentheses 3a minus 1. So the variable is on the right-hand side. So our goal here is to get everything on this side away from the a. Now the only way that we can do that is by getting rid of the parentheses. So what has to happen first on problem number 2? What do we have to do first? Elle, what do you think? Do what? Yeah. We have to take our -7 and distribute it. So -7 times 3a minus 1 means the -7 multiplies by the 3a, and the -7 multiplies by the -1. So we're going to distribute that -7. Distributing means multiply to both things inside the parentheses. So on the left-hand side, 91, that's still there. -7 times 3a. Remember, when you're distributing, you're just multiplying the numbers together. And if there's a variable, leave the variable. So -7 times 3 is -21 with the variable. So -21a. And -7 times -1 is +7. Now, step 2, it says to combine like terms. I don't see any like terms here that can be combined. So if you want to, you can put the little if possible in step 2 as well, because we're going from step 1 to step 3 on this one, because -21a plus 7, those are not like terms, so I cannot add those together. Something with a and a regular number cannot be added together. So there are no like terms here to add or combine or anything like that. So what we need to do now is move on to step 3, which is to solve, and it's usually about 2 steps. And if we look here, this is a 2-step equation. So if I'm trying to get a by itself, what's the first thing I need to do to solve for a once I get to this step here? Do what? What do we think? How do we get a by itself? What's the first thing we have to do once we get to this step? Subtract 7. Yep. On the right-hand side, 7s cancel out, and we still have a -21a. So -21a. 91 minus 7 is what? 84. What's our last step? What do we do to get a by itself? Divide by -21. If we divide by -21, the variable is all that's left on the right, which is exactly what we wanted. We wanted to get the variable by itself. That's going to be -4. So a is equal to -4. Example number 3. Again, if you have questions, raise your hand. Something is like, hey, why did we do that when we did that? Please ask. I'm happy to go back through whatever we need to make sure that this is making sense. Otherwise, we'll take a look at number 3. So, problem number 3. What do we have to do first on number 3? Does anybody think they see what has to happen here? Distribute. Good. I like it. If you have parentheses, chances are you're going to need to distribute. And we are distributing here. What are we distributing? What is it? -5. Good. You always distribute the value that is right up against the parentheses. The value that's right up against the parentheses is, it's not 5, it's -5. So when you distribute the number next to it, always circle the symbol to the left, whether it's a plus or a minus, always circle that symbol, because that tells you whether or not you're distributing a positive value or a negative value. So we have 4m minus 5 times the quantity 3m plus 10. So we have to get rid of the parentheses first. We have to unlock what's inside the parentheses. Let's see, we haven't done anything on the right-hand side, so that's still 126. We haven't done anything to the 4m over here either, so that's still 4m. But when you multiply negative 5 times 3m, remember you are multiplying the regular numbers together. Negative 5 times 3, that's negative 15. And the variable is still there, so that's negative 15m. And then you're also multiplying a negative 5 and a positive 10. Negative 5 times positive 10 is negative 50. So after we distribute, we get 4m minus 15m minus 50 equals 126. And then we look at step 2 once we have that. Are there any like terms that can be combined? Remember that when you combine like terms, it's always going to be on the side that has multiple terms. So 126 over here, can't do anything about that. But on this side, is there anything that we can put together to combine as like terms? Meaning, are there multiple regular numbers or are there multiple things with m? 4m minus 15m, good. So this 4m and this negative 15m, they both have m, which means we can put them together by taking 4 minus 15. Again, if you are struggling with integer operations, 4 minus 15 is going to give you negative 11. So when you combine the 4m and the negative 15m, 4m minus 15m is negative 11m. And then minus 50 equals 126. Once you've combined your like terms, it says to solve, and this is usually about 2 steps. If we take a look, that's a 2-step equation, just like we've been seeing over and over. So this 2-step equation that we have now, what's the first step? What do we have to do first to solve that? We're going to undo the subtraction first. So what do we have to do? Gabby? Add 50. Yes, I like it. So add 50 to both sides. On the left-hand side, negative 50, positive 50, those cancel out. Bring down a negative 11m because that's still there. 126 plus 50 is 176. What's our last step? Divide by negative 11. Write the answer up over here. I ran out of room. Oh man, let's see. 20, 11, what's that going to be? What's the answer to that one? Negative 16. All right. Negative 16. I like it. There's our answer for that one. So distribute, combine like terms. Once you've done those things, we end up with a 2-step equation, which should look just like the ones that we did on our test and last week and on the review and everything like that. Problem number 4. Do you see parentheses? Yeah? In more than one place, right? Okay. So for this first set of parentheses, what am I distributing? Negative 3. Good. I distributed negative 3 to that first set of parentheses. Something I noticed on the review, on the assignment for this kind of thing when we were combining like terms and using distributive property, was there are some people who are distributing the thing on the far left. So listen carefully here. There's some people who are distributing this thing on the far left to the first set of parentheses and the second set of parentheses. Keep in mind, you only distribute the value that is right next to the set of parentheses into that immediate set of parentheses. So this negative 3 only distributes to the k and the negative 8. The negative 3 does not distribute to this k or that 5. Because there's something in between And this -3 is not right up against this set of parentheses. What is right up against this next set of parentheses? A minus, which is the same as what? A -1. Anytime you have a minus, and I've said this a few times, and I'm going to keep saying it, anytime you have a minus right up against a set of parentheses, that is the same as having a -1. So I'm going to actually put a 1 in between the minus and the set of parentheses to remind myself, hey, that's not just a minus, that's a -1. So into the second set of parentheses, I am distributing a -1. So -1 times k, -1 times 5. Now we can go ahead and distribute into both sets of parentheses, -3 into the first set, -1 into the second set. So -3 times k is just -3k. -3 times -8, two negatives make a positive, 3 times 8 is 24, so that's -3k plus 24. -1 times k is -1k, and -1 times 5 is -5. So we distribute, our parentheses are gone. That's a good thing. We can't have parentheses if we're going to try to solve this. So the next thing we need to do, if we can, is to combine like terms. And I do see like terms because now number 4 looks a lot like number 1 did. So I see 2 terms with k, and I see 2 terms that are regular numbers. So I'm going to identify my terms with k. So I have a -3k, and I have a -1k. Remember that anytime you are putting your shapes or whatever around the terms that are like terms, always include the symbol to the left of the term. If it's a plus, make sure that you include the plus when you circle it or put a box around it. If it's a minus, include that as well. And then we have a +24 and a -5. So we've done step 1, distribute. Step 2, combine like terms. -3 minus 1. Once again, if you are thinking it's like a 2 or a -2, it is not. It is a -4. Make sure you're using a calculator if that's what you need to do in order to get these done correctly. Right now, you are not being tested on your ability to deal with integer operations. That's why I'm saying, yes, use a calculator if you need to. Right now, we are learning how to learn the process of equation solving. And so if the calculations are what's tripping you up, use a calculator. All right, so it's going to be, when we put those together, -3 minus -3k minus 1k is -4k. 24 minus 5 is 19. So 4k, -4k plus 19 equals 23. -4k plus 19 equals 23. Step 3, solve. Usually about 2 steps. Look at what we have, 2-step equation. What do we do next? What's our next step? Got 2 more things to do. What's the first one? Subtract 19. Which means I've got -4k. 23 minus 19 is 4. Last step, what do we do? What is it? Divide by -4. What does k equal? -1. I also want to make this very clear. You are not going to be able to, and I'm just going to go ahead and say this, you are not going to be able to figure these out just by looking at them and trying to figure out what the variable is equal to. Even if you have a calculator and you're just punching stuff in and you're trying to figure it out without writing something down, it's not going to happen. Go through this process, write it down. I know it takes a little bit of time, but if you don't work through this process, you're not going to be able to really get to the right answer. If you're just plugging things into your calculator or you're writing something here and there and it's not organized and you don't really know what's going on, this process will not work. It must be done in a very step-by-step organized way. The other thing about it is if you look at a problem like this and you're like, I don't know what x is, it could be a little bit overwhelming if you're just trying to figure it out all in your mind, especially when you have x here and a whole bunch of stuff going on. So if you go back to these steps, the reason why we're breaking this down into steps is because you can do that. You can distribute, I know that. You can combine like terms, I know that. You can solve a two-step equation, I know that as well. So if you break it down and just do one thing at a time, as opposed to trying to figure out the whole thing just by looking at it, it's going to make life a lot easier. Start by doing one thing. Look for something else you can do after that. But if you try to do it all at once, it's going to be a challenge. It's kind of like if you get behind in schoolwork, and you've got a bunch of stuff that you have to catch up on. If you try to think about doing it all at the same time, it's just going to be overwhelming. And you're going to be like, I can't do this. But if you're like, you know what, I'm going to pick one thing to do, and I'm going to do that one thing. And then you move on. You're like, oh, I can do one more thing after that. So if you do one thing at a time, you're good to go. If you think about it all at once and try to do it all at the same time, it can feel a little bit daunting and a little bit overwhelming. So let's go ahead and finish up this first page. Problem number 5. Do we see parentheses? Yeah. What number is right on the outside of those parentheses? -6. Good. It is not the 10x. The 10x is not right next to parentheses. The -6 is. And thank you for saying -6. So we're going to take our -6. We're going to distribute it to the 2x and to the 5. So our next step, we haven't done anything with this 20. There's our equal sign. We haven't done anything with the 10x either. We have done something with this -6. We're multiplying it by 2x. So -6 times 2 is -12. With an x is a -12x. I'm just going to write -12x. Some of you might have noticed that I interchanged the words negative and minus. That's because they're the same thing. So when you say minus or negative, like if it's by itself, that says -12x, 10x minus 12x. But if I cover it up, that's just a -12x. So a minus and a negative, really no difference in terms of what they mean mathematically. -6 times +5 is -30. So we've distributed. There are no more parentheses. Are there like terms that we can combine here? If there are, they're on the right-hand side because there's only one thing on the left. So do we have like terms over here? What are they? The 10x and the -12x. Yes, so 10x, -12x, those can be put together. 10 minus 12 is -2 with an x, means -2x. So I'm going to have 20 equals -2x minus 30. So step 1, distribute. If possible. Yeah, it was possible. We did it. Step 2, combine like terms if possible. Yeah, we had like terms, so we did that. Step 3, solve. Usually it's about 2 steps. Look at what we have. That's a 2-step equation. So what do we do next? Get x by itself. What's our next step? Add 30. Good. So plus 30 here, plus 30 here. -30, +30 cancel out on the right. I still have a -2x over on the right-hand side. So -2x, 20 plus 30 is 50. Final step, what am I doing? Divide by -2. $50 divided by -2 means that x is equal to -25. Okay. That is it for the first page. We've done 5. We've got 4 more on the next page, plus a bonus, which we'll take a look at as well. So we got a few more to get through. Are there any questions so far on this first page? All right. So we're not always going to do either step 1 or step 2. We're going to do at least step 1 or step 2. A lot of times we'll do both, but we won't always have to do both. All right, moving on here. Number 6. Let's see. I'm going to go ahead and get my equal sign, vertical line straight through there. We do have parentheses. So that means we will be distributing. What number is getting distributed? 8. That is the number right on the outside of the parentheses. So that means that 8 gets multiplied by the 2w and the negative 1. So 8 times 2w, 8 times 2 is 16, with the w is 16w. 8 times negative 1 will be a negative 8, minus 8, and then minus 4w, that's still there, equals negative 116. Step 1, distribute if possible. It was possible, we distributed. Step 2, combine like terms, if there are like terms. Are there like terms? Yeah, which ones are they? 16w, what else? Negative 4w, good. So 16w minus 4w, 16 minus 4 is 12. So that's 12w. Negative 8, or minus 8 goes after that. There wasn't another regular number to put together over here, so that stays as a minus 8 or a negative 8. And then that's equal to negative 116. So we've distributed, we've combined like terms. Now we solve. Usually it's a two-step equation. Look at what we have. That's a two-step equation. So what's the next step? Add 8. All right. So 12w. Again, you're having trouble with integer operations. Negative 116 plus 8 is negative 108. Yes. I missed that one there. Thank you. This will be good for when we divide. Otherwise, it would have been way off. So yeah, 12w. And then our last step, what are we doing? Divide by 12. Good. So negative 108 divided by 12. What is it? Negative 9. Yeah. So W equals negative 9. All right. Next thing I'm going to show you here, number 7. What I'm about to do not do. I'm going to show you something incorrect on number 7. There is a set of parentheses, which means we are going to use the distributive property, but we are not going to do what I'm about to do. So don't do this. Here's what I see sometimes with a problem like this. Why are we not going to distribute 11h? Because that's, in terms of a number, that's the number that's by the parentheses. So why does that not work? Right? Yeah, because the 11 isn't exactly bumping up against the parentheses. The thing that is the minus. And as we saw on problem number 4, if you have a minus right up against the set of parentheses, what does that mean? Negative 1. So the 11h is not right up against the set of parentheses. We are not distributing 11h. We are distributing the negative, which is a negative 1. So when we distribute to our parentheses, we are taking our negative 1 and multiplying it by 2h and by negative 1. Meaning that the 11h stays the same for now. Negative 1 times 2h, negative 1 times 2 is negative 2, with an h would be minus 2h. And then negative 1 times negative 1 is a positive 1. And then that equals 118. So when we distribute, it's always the thing that is literally like connected with the parentheses. If there is a value and then a plus or a minus in between that value in the parentheses, then we are not going to distribute that thing on the other side. It's always what's right up against the set of parentheses. Are there like terms that we can combine on this one? Do we have like terms here? Yes. Okay. So which ones are they? Which ones can we put together? 11h and the negative 2h, or 11h minus 2h. All right. 11 minus 2 is 9. So that's 9h, and then plus 1. There was not another regular number over here on the left side of the equation to put together with another regular number, so it stays 1. So we distribute it, we combine like terms. Step 3, solve, which is usually a two-step equation, and there we have it. That's a two-step equation. What's our next step? Subtract 1 from both sides of the equation. Let's see, bring down the 9h. 118 minus 1 is 117. What's our last step? Divide by 9 on both sides of the equation. All right, so divide by 9, divide by 9. And that's what, 13? H equals 13. All right, we got 2 more. And then a translation problem at the end there. So number 8. We've got a set of parentheses. There's a number on the outside. What number gets distributed? 1/2. We're distributing 1/2 to the 10x and to the negative 2. Only to the things inside the parentheses. This plus 3x on the end, that's not on the inside of the parentheses, therefore we do not distribute to the 3x. So on the left-hand side, we still have a negative 25, and now we're going to write equals 1/2 times 10x. What is half of 10? 5. Yeah, half of 10 is 5. So half of 10x would be 5x. So that's 5x. What's half of 2? 1. But it's a negative 2, so it'd be negative 1. So half of negative 2 would be negative 1, or 5x minus 1. Don't forget about the plus 3x, that's still there. And then the next step, if we can, combine like terms. Are there like terms that we can combine? I see a nod. Where are they? Which ones are they? 5x and the positive 3x. On the left-hand side, we still have a negative 25. Haven't done anything with that yet. 5x plus 3x. 5 plus 3 is 8, so that's 8x, and then minus 1. So we've distributed, step 1. We've combined like terms, step 2. Step 3, solve. Usually a two-step equation. There it is, a two-step equation. What's our next step? What do we do now? Add 1. Negative 25 plus 1 is negative 24. 8x is still there, so we bring the 8x down. So negative 24 equals 8x. What's our last step? Divide by 8 on both sides. And we get x is equal to what? What's negative 24 divided by 8? Negative 3. So if this feels repetitive, it's because it is. We're kind of doing the same thing over and over and over. It looks a little bit different each time, but the actual steps that we're doing are pretty much the same thing every single time. Distribute, combine like terms, add or subtract something to both sides, and then multiply or divide something on both sides. I don't think we've had to multiply on both sides yet, but that is a possibility. So last one here of our regular types, number 9. What are we doing first on this one? Are we going to distribute on this one? Is that a yeah? What are we distributing on this one? Negative 5/2. Yes. So again, we have these that we can use. If you want to use a calculator to do this multiplication, have at it. So I'm going to take my negative 5/2. I'm going to distribute to the 8r and the negative 6, only to those two things. So when I write my next line underneath here, I've still got 32 on the right. I haven't done anything with this 7, so I'm going to write 7. Negative 5/2 times 8 should be negative 20. But if you need to use a calculator for it, these calculators have a fraction button. This little n over d button, numerator over denominator. There's your fraction. Negative 5 over 2, that's negative 5 halves, times 8. There it is, negative 20. If you need a calculator to do the calculation for you, please have it do that. So I'm going to write minus 20r. By the way, these calculators will not do variables, so don't bother trying to put a variable in here. It's only going to deal with the actual numbers. So when you're multiplying these, leave off the variable and then just put it on when you write it. So just do the calculations with the numbers. And then negative 5 halves times negative 6 should be a positive 15, but again, you can always double check. So negative 5 halves times negative 6, there it is, positive 15. So I'm going to write 7 minus 20r plus 15 plus 2r equals 32. So that's my next line right there. Do we have like terms that we can combine on this one? Yeah, all right. Where are they? So negative 20r and a positive 2r. Okay, anything else? What? 7 and 15. Positive 7, positive 15. The variable terms, negative 20 plus 2 is negative 18. So that's negative 18r. 7 plus 15 is 22. So plus 22 equals 32. From there, what's our next step? What is it? Subtract 22. I like it. By the way, the answer on this one is going to be a little bit different than what we're used to, and I'll show you in a second what I mean by that. 22's cancel out on the left. We still have a negative 18r over here. What's 32 minus 22? 10. All right. What's our last step? Divide by negative 18. All right. Now, what's different about this one than the other ones? It's not going to be a whole number, is it? No. That isn't a problem. It's okay to get a number that isn't a whole number. I know that pretty much all the answers we get have been integer solutions, pretty much, but not all of them. There are times where our answers are not integers. The reason why they are integers is because it makes it a little bit simpler, I think, to work through it and know that you're going to get an integer answer. However, these problems are written, most of these problems are written intentionally to have integer answers. When you solve an equation, there will never be a guarantee of a positive or a negative whole number. That is not how equations work. And I don't want you to get the wrong idea about equations, because when you solve an equation, the answer doesn't have to be a whole number. It doesn't have to be a positive or a negative whole number. It could be anything. It could be the craziest fraction you've ever seen as the answer. It could be irrational as well. We won't see that in this class, but that is a possibility. So just because we see mostly positive and negative whole number answers here doesn't mean that that's how equations actually work. It's not really how they work. It's just done more out of convenience for you as you are learning this process. So R is equal to, by the way, this negative 18 on the denominator, it doesn't matter that that's on the denominator. I'm going to rewrite this with it off to the side, like that. It could be on the denominator, it could be off to the side, it could be with the numerator. That negative doesn't really matter where that negative goes. However, am I done yet? No, I see a couple of people shaking their heads no, right? Or why not? It can simplify, yeah. And I mentioned before, a long while back, when we were talking about fractions, like that second week of school, I said, if a fraction can be reduced, my expectation is that you reduce it. I am not going to give you reminders in the notes to reduce your fractions. That is something that you should be doing automatically. So make sure that happens. These are each divisible by what? By 2. All right. So R is equal to negative 5 ninths. Cool. That's the answer to that one. That's a fraction answer. It's okay that we get a fraction answer. All right, last one. Number 10. 5 times the difference of a number and 3 decreased by the sum of a number and 8 equals 13. First thing I want to call out on this one. When you see the words times the difference of, what does that mean? It means parentheses. We took notes on our translation assignment or our translation lesson where we had parentheses phrases and we had turnaround phrases. Parentheses phrases, if you saw the words times the difference of, that means you're going to open up a set of parentheses. On this last one here, we see the words times the difference of. That means parentheses. So we're going to do 5 times the difference of means we're going to open up a set of parentheses. What are we finding 5 times the difference of? Twice a number and 3. Twice a number means 2 times a number, or 2 times our variable, which we can call x. The difference of that and 3 means 2x minus 3 because difference means subtract. Decreased by means minus. The sum of, by the way, the sum of, what does that mean? It does mean addition, but decreased by the sum of, that's another parentheses phrase. Decreased by the sum of the number x and 8, the sum x plus 8 equals 13. That is our equation. And what I would like you to do is take 3 minutes and solve that. You are going to distribute twice. And just to help you out, this minus in between here, that's like having a -1. So I'm going to give you 3 minutes to solve that. And then we will double check our answers. 3 minutes. Freeze this. We'll check in on our solution in a few minutes. So follow those 3 steps. Distribute, combine like terms, and solve. Take a look here. A little guidance there if you need it for what to do first. distributing. All right. What does the next line read? Who has the next line? Justin, what do you have? Nice. I like it. Yeah, that's great. So 10x minus 15 minus 1x minus 8. If you wrote plus -8, that's totally fine. It means the exact same thing as -8. Excellent. From there, you can see I've identified some like terms. We've got the 10x, the -1x. Those go together. We have a -15 and a -8. Those go together. Does anybody have the next line? What does the next line read? Once you combine your like terms, what does the next line read? What do you have? 9x minus 23 equals 13. Good. 10x minus 1x is 9x. -15 minus 8 is -23. Or -15 plus -8. Same thing, -23. All right. We are now at a place where we are going to solve, meaning we're basically at a two-step equation now, which is true. I shouldn't say basically. We are at a two-step equation now. So we got to get rid of the -23. How do we do that? Add 23 to both sides. When you add 23 to both sides, the 23s on the left cancel out. You're left with 9x. 13 plus 23 is 36. So 9x equals 36. The final step. I went ahead and just rewrote the whole thing up here. You'll notice I just did an arrow because I ran out of room. So I just rewrote the 9x minus 36 at the top of that next line over there. If you run out of space, this is something that you can do. If you're just working straight down and you're not using your own paper, feel free to do something like that. Divide by 9. What does x equal? 4. X equals 4. Nice. Okay. That is it for our notes. That is it for multi-step equations.